Hey everyone, welcome to Singularity Computers Modding, Episode 3. Today I'm going to take you through how I do my custom wiring, which is something I've covered briefly many times in previous videos, but I've never done a full custom wiring guide. I'm going to start this video by taking you through the tools and materials that you need, and there's definitely a lot to become familiar with, mainly if you're going to be doing custom wiring for your entire build and not just for the core components, which is what a lot of people do. I mean, custom wiring for the core components is definitely going to make a big difference for your build, but what about the rest? You know, you're still going to run into the same old problems of having a whole lot of extra wiring mess for everything else. Peripheral, fans, lighting, pumps, mainly if it's a high-end water-cooled system, like the one that I'm currently working on here. I'm going to get straight into it because there really is a lot to cover, and this is actually the 5th time now that I've shot this video, because it ends up being far too long, up to an hour long, because there's just so much to cover for custom wiring. And, you know, I really want to try to cover as much as I can. What I have here is the custom wiring for the core components, and I've been outsourcing this for a long time now. I have someone employed who does it locally, and I also send some of it to IceMods. And this has been done by IceMods. You can see that he's done an amazing job here. Heatshrink sleeving, MDPC-X, incredibly high quality, all black except for the blue streak, which matches up nicely with this build, which by the way is Client Build 20 Event Horizon. So very good match there, and just one streak, so it's nice and subtle. Included cable combs, absolutely beautiful. 3 of them on there. He's just done an amazing job. You know, one thing that you always look for, I mean, first of all, the ends here, if there's any kind of, you know, melting or anything there, you know, the quality isn't so good. And also that all of the cables are exactly the same length. If they're not, you'll have cables sticking out here and there. And also bunching of the sleeving, so that's how I know that these are incredibly high quality. So what I mean by custom cables for core components, we have here 24-pin, 8-pin EPS, 4-pin ATX, which is what this motherboard needs, which is the MSI Godlike Gaming X99A, and also all of the PCIe, so 2 6-pin, 2 8-pin. So that's for the motherboard, CPU graphics, core components. In a high-end water-cooled system like this one with dual loops, 20 fans, and a Quero 6, that only accounts for about half of the custom wiring. And for nearly a week now, I've been doing custom wiring for this build, as well as a few other things. A lot of time has gone into it. I just thought I'd mention at this point that you've probably noticed by now that this is actually a two-tone paint job. It has 2 special effects. They're custom blue pearls. And I haven't talked about why I did this yet in the build log, but I will coming up in part 3. And this is actually a bit of a sneak preview to what's coming up in part 3, because as you can see, if you've seen part 2, I've done a fair bit of work since then, but I won't give away too much, and it's only a sneak preview to the beginning of part 3. So you can see what I'm working on here and how much wiring there is to be done. 20 fans, I mean, I have splitters here. I've customized the lengths of everything, and that's what's really so important, is not so much having good looking wiring and sleeving, because a lot of it is hidden around the back of the build anyway. It's having those correct lengths. It just cleans things up, improves the quality, performance. So that's what I love about doing custom wiring for absolutely everything. I have the Aqua Computer Farbwork RGB LED lighting controller here. You know, so many little extras that really increase the amount of wiring that needs to be done. Just the Quero alone accounts for half of the extra custom wiring that I need to do in this build aside from the core components. So let's get started here with the tools that you are going to need. First up is a nice sharp pair of high quality scissors. Wire strippers, you need a burner. A lot of people use cigarette lighters, but I don't like naked flame, and this is specifically designed to do heat shrink. No naked flame, burns at the correct temperature, which is I think 600 degrees Celsius, I believe. Just a beautiful little tool. You know, this is about 3 years old. You can refill it. It has a lighter inside. You just get some lighter fluid and you can use it over and over again, and I definitely recommend this for beginners. I will put links in the video description to absolutely everything, all of the tools and materials. So this will be a full guide with links to everything that you need to do custom wiring. And it's really just about getting in and giving it a go. You know, in the beginning you're going to fail. It's very difficult, it's time consuming, it's frustrating. You just need to keep trying, experimenting, practicing. Eventually you'll get there and do some beautiful wiring. Nice high quality sharp side cutters, some nice sharp needle nose pliers. Crimpers, you can't just get any old crimpers. You have to have crimpers that are especially for this. I suggest MDPCX, but I have fallen in love. I really like these ones because they have extra. The MDPC ones only have 2 crimps. This one has 3. And because I do so much weird custom wiring for, you know, power and reset buttons, front I/O, I like to have these different sizes. And you can also see the shape of these. They have a nice sharp, the middle section there, it really crimps nicely. They're also nice and small and compact. So I'll put a link to the MDPC ones and also these. And you also should have these, which are for removing connectors. You know, you can kind of do without them, but I suggest getting them. This is for removing Molex connectors, female, male, on each end. This is for fans, 3-pin and 4-pin. And this is for ATX. Beautiful little tool from MDPC. So that's all of the tools that you need. Let's get started on the materials. Now really, you're only going to need 18 gauge and 22 gauge. Basically, most manufacturers use 18 gauge for the core components, but as a little quality perk, I like to use 16 gauge. This is actually 18, but you know, you only do that if you want to go that little bit further. 18 is, you know, plenty, more than enough, and it's going to definitely do the job. And also 22, some people will say 26, but 22 and 26 are so small anyway, and really as long as the wiring fits the pin, then no worries. And you're better off having something a little bit bigger. So I prefer to just use 22 instead of going down to 26, which is incredibly small. So that's what that is there, 22 gauge, and I'm set up here to do some fan wiring. But basically, core components and most things, peripherals, hard drives, pumps, will be all 18. It's only fans, lighting, and a couple of other little details that will be 22. So get yourself mostly 18 and just a little bit of 22. I can't say exactly how much, obviously it depends on the build, but just get yourself more than you need because it's not really that expensive anyway. Pins, if you're doing just custom wiring for core components, it's simple. You only need these ATX pins. So it becomes a lot more complex if you're going to do custom wiring for everything else because you're going to need Molex, male, Molex female. So not many of these, mostly these. You can actually count out exactly how many of these that you need. Obviously 24-pin, 8-pin EPS, 6-pin, 8-pin PCIe, but get plenty of extra. For these you can't really count them out because it just depends how you're going to configure your wiring. You really need to get stuck into the system first. Fan pins, these are the female. I'll show you how the male works in a sec. And these are USB. Now these are not just used for USB, they're also used for things like lighting and also this. So front panel I/O, power and reset buttons. And I do not like these little connectors. All of these little connectors are a mess. So I cut them off, repin, that's where these pins come in. And instead of all of those little connectors, I use 1 or 2 USB 2 connectors like this. So it really cleans things up. It's something you can see in previous videos. And I will also briefly cover it in part 3 of the Client Build 20 build log. So you can see how that's done there. Now, these are SATA power. And you actually only need these pins if you use the straight SATA power connectors. I'll show you what I mean by that in a sec. So that's all of the pins you're going to need. Next up, connectors. You need one 24-pin, You need however many graphics cards you have, you know, for 6-pin and 8-pin PCIe, 8-pin EPS, 4-pin ATX possibly, depending on your motherboard. You can see my collection of connectors there. So that's the core components. Now you need Molex male, Molex female. You also have the option of a 90-degree Molex connector, which doesn't require any pins. So you can eliminate the need for all of the Molex pins and different types of connectors by just grabbing one connector, the 90-degree version. But it really depends on what you're doing and if 90 degrees is going to suit it. That also goes for SATA. This is the straight connector that you need the pins for. You know, they kind of look complex, but they're really not. They crimp on just the same as any other pin and plug straight in, so they're no big deal, but you can avoid it by getting 90-degree SATA power connectors, and a lot of the time you're going to need these anyway, depending on how you've configured your hard drives or SSDs. If they're stacked, 90-degree connectors are awesome, and they're going to be stacked in this build, which is why I have prepared here a bunch of connectors. So 4 SATA power connectors, which will be stacked on top of each other on the one cable. And for all of the 90-degree connectors, you get these little backs, and there's 2 different types. One is for when the wires go through, and one is for the final connector on the cable where the wires end, to cover the ends of the wires. And this is just obviously to improve the aesthetics, to cover things up. Fan connectors, you're definitely going to need these female connectors, 3-pin, 4-pin, depending on what you're doing. These are the male connectors, and if you're going to get these, you need to solder. And I actually soldered for this build, and I've done it before, very time-consuming, very difficult, because if you even slightly overheat these, the pins fall straight out of them. So very difficult and time-consuming, and you can avoid this by just grabbing yourself some fan extension cables if you need them, depending on the fans that you have and the size of your build. Certainly for a build like this, you need extension cables. So the reason, you know, for absolutely everything, I recommend building your cables from scratch. For your core components, you know, back in the old days, people used to modify their existing power supply cables most of the time. A lot of people will still do that, but you can completely control the quality of the cables from the ground up if you build them from scratch yourself. You can pick the best materials, you can do the best possible job. I prefer to have complete control over that and do everything from the ground up that I possibly can. But if it's going to save a huge amount of time, which this definitely will, then yeah, just grab some extensions, cut them down to length, which still means, cutting them down to length means you can eliminate these. You know, getting extensions that you'll cut down to length, eliminate these, eliminate the need for soldering, but you're still going to need these, the female connectors and the pins. And cutting extensions down to length is often what I'll do for a lot of builds. So that is it for connectors. Let's move on to sleeving. You're only going to need 2 types of sleeving, generally. I only use 2 types. So this is the common type. You're going to need a whole lot of this, because it's for just about everything in the build, like 98%. And this will be listed as, I don't know, maybe ATX, maybe it's size. I'm not sure what it is in inches or millimeters, but very common. A lot of different brands out there, different colors. Lots to choose from. This is MDPCX, and it's the only thing I'll use. I love it. You're also going to need a bit of sleeving for SATA data cables. That's if you're actually going to have any SATA data in the build. So that's what that is. And then to suit the sleeving sizes, 2 different heat shrink sizes. This one for the smaller one, this one for the SATA. Now, get extra for the SATA because you're going to use it for different things, not just SATA data cables, SATA data for the Americans. So you can see here I've used the SATA heat shrink for fans. And there's a whole lot of fans in this build, so I need a whole lot of it. Not just that, but the power and reset buttons, I've used it everywhere. You use a lot of it. You can also see I've used a bigger heat shrink there. And that's why I also like to get a bit of a bigger heat shrink, not just for vandal switches, And by the way, the reason I've gone right up to the back of them like that with heat shrink, you know, a lot of heat shrink often will look ugly and you minimize it as much as possible. Bring your sleeving as far as you can, minimize heat shrink. But I've done that there because the backs of those buttons are so ugly. You know, there's pins everywhere, wires everywhere, so you're better off covering it up with heat shrink. It looks so much better. So that's where this larger size comes in, and I definitely suggest grabbing it. So that's it for tools and materials. Now the first thing that you're going to need to do if you're going to do custom wiring is figure out the length of the cable you're going to be building. Now this is very simple. I have a simple technique I've been using for this since the beginning. I have a roll of 18 gauge wire here, which I use every time, and all I do is lay this in the exact position and routing that I'm going to be running my cable. For example, say I want a cable to go from the bottom of one of these pumps all the way up to the back of the Aquero 6 here. I hold the wire on the back of the pump there with my finger, obviously unroll it, run it through the gap wherever I'm going to be running the wire, come around here, you know, hold it here, run it across to here, hold it there, and just run it all the way up, you know, in that corner across there, wherever you're going to be running it. And right from the beginning for custom wiring, you need to start thinking about your cable management, because you can see here I have a lot of different cables following the same routing, and they're not managed yet. They're going to be very clean once they're done. But instead of having, you know, one cable length that runs down here, one over here, run them all in the same spot. It's going to be a lot cleaner. You may need to add a bit of extra length, but you obviously need to be thinking about this right from the start when you're getting your lengths. Where are you going to route these cables for the cleanest possible aesthetics, and what lengths are you going to need to be able to do that? So that is how you sort out your lengths. Okay, let's get started. I'm going to start with the most common cable type, which is 18 gauge wire, ATX pins. First thing you need to do is strip the ends off the wire. And how you know how much to strip is by looking at the pin. There are two different crimps on each pin. And I'm going to call this one on the back crimp 1, and this next one in here crimp 2. Crimp 1 crimps onto the insulation of the wire. Crimp 2 crimps onto the wire itself. Now, if you can just imagine the amount of power, electricity flowing through some of these wires for your graphics cards, for example, and it only has one tiny little contact point right here where it crimps onto the wire. If you don't perfect that crimp, if that contact isn't perfect, you are definitely going to run into problems. And the sort of problems that are going to be very hard to diagnose, damaged components, cause you a lot of headaches and problems. You know, this is not a game. This is something that you need to get absolutely perfect. You know, total quality control here. Triple check everything, spend the necessary time, and take the necessary care. Otherwise, absolute nightmares will occur. So, yeah, you can see the length of the second crimp there. Well, that is the length of wire that I need. So just estimate it. You're better off having more than less. So keep that in mind. Doesn't matter if there's a bit of overhang up inside the pin, but if there's not enough, then I often just give them a little trim like that. But you do have to be very careful doing that. I only trim off less than a mil, just because you're going to possibly change the length of one of your wires. And after you have your, this is the first thing I should have mentioned, after you have your cable length, you know, it might be one wire in the cable, it might be 4 wires or 5 wires in the cable. Well, you need to cut them all to exactly the same length. Otherwise, you're going to have a lot of problems later. So let's just say there's 2 wires in this cable, and well, actually they're not the same length. I need to make sure that they're exactly the same length. Otherwise, what I mentioned earlier will happen. One wire will stick out. It just looks terrible, like an amateur mistake. So get those lengths right. A little bit of extra on the strip. And make sure you choose the correct hole on the strippers. Otherwise you're going to end up stripping, well, cutting off some of your wire strands. And then you're going to run into contact problems again. And that's the last thing that you want. So a lot of care should be taken. Time to crimp on the pin. So sit it on there. What you do is run the insulation all the way up to the back of crimp 2. So through crimp 1, touching the back of crimp 2, but don't run it inside crimp 2. That is only for the wire. If you run it inside crimp 2, you're going to run into contact problems yet again. Now this is where the needle nose pliers come in. I'm just squeezing very, very slightly crimp 1, the insulation crimp. You don't squash it, crush it, anything like that. You just want the pin to hold on to the wire enough so that it isn't just going to fall off as you're grabbing your crimpers. And this is important because you don't have enough hands or fingers to hold the pin in position while you're trying to crimp it. And if you attempt that, you're going to run into problems. If that pin falls out of position, again, contact problems. Now don't worry about the alignment on the inside of the crimpers here. Just don't even look at that. Look at the outside. Also pick the hole size, the crimp size. For this pin, it's the middle one. Molex is a bit bigger, the outer one, and then lighting fans is the small one. So the middle one. Now you need to line up crimp 2, which is the one that crimps onto the wire, exactly with the side of the crimpers there. Squeeze it all the way until it's fully clamped, compressed. And a good crimp, you can see there, the pin is still the same shape that it was, because that's something you need to be careful of, is that you don't change the shape of the pin, end up bending it, crushing it, anything like that, or it's not going to fit into the connector, and it's not going to get proper contact. But you can see here, the insulation crimp is nicely bent around like that and stuck in on both sides. Nothing is snapped off. That is a perfect crimp. Same on the wire. Absolutely beautiful. So first of all, you look at it to make sure it all looks good, and then you grab it and you pull it as hard as you can without damaging the pin. And if it doesn't pull off, you've done a great job. But you know, it both has to look good and not fall off. So actually, I'm just going to forget that other wire. I'll crimp this pin on the other end, and then I will take you through sleeving, heat shrinkless, and heat shrink. Okay, that one was a little bit more messy, but it'll certainly do for this. I'm actually leaning over the camera here, very difficult position. Okay, the next thing you need to do is cut your sleeving to length, and this is actually a little bit difficult because a lot of it is guesswork. Depending on how many wire strands you have inside the sleeving, depending on the gauge of the wire, depending on whether you're doing heat shrink or heat shrinkless, there's so many different things which change the length of sleeving that you need. But this is something that you need to experiment with and you need to figure out for yourself, and keep in mind that if it's too short, you need to do it again. If it's too long, you can cut it down. So you're better off going longer than shorter. What I'm going to do for this, considering that one end is going to be heat shrink, the other end is going to be heat shrinkless, and you know, this is going to be pretty much useless information to you guys. But you can use different positions on the pin to measure the lengths that you need, and usually for something like this, I would go from the end of the insulation on the wire to the end of the insulation on the wire. And the reason that, and by the way, this is where the sharp scissors come in. I prefer not to cut my sleeving with side cutters or anything else. Nice sharp scissors will give you a good straight cut. After you've cut it, you need to melt the end. It will want to expand, so you then shape it a little bit. The whole point of melting the end is obviously so that the strands stick together on the end, so it does get a little bit messy, but you don't want to have any strands that are separate, otherwise it's going to fray. And then you're going to run into problems. So there we go, that piece of sleeving is all ready to be threaded onto the wire. So very easy on a short cable, but on a long cable you need to do a lot of this to push it on. And it also likes to get caught on the pins, so it can be a little bit difficult. But you can see the length is good. And it's now time to, well, I'll show you heat shrink first, because actually, you know, I was going to say it's better for beginners to do heat shrink, but really it's not. Heat shrinkless is easier, stronger, looks better. In my opinion, it's superior in every way. Now, for heat shrink, you need to line up your sleeving about 5 millimeters back from the end of the insulation. Okay? So where the insulation ends, 5 millimeters back, roughly. And then thread on your heat shrink. The heat shrink needs to go up to the, over the first crimp, the insulation crimp. Heat it up again. Now don't heat it too much where the heat shrink burns, because the heat shrink, you know, it will burn, it does look ugly. You need to then start again. Just enough to shrink it down nice and tight. So there we go. Now, it looks fine now, but the real test is when we plug it into the connector. Because if we've come too far forward on the pin, it's not going to fit. If we've come too far back, it's not going to have anything to grip onto. It's going to slip off a lot more easy. It's not going to have the strength. And you also might even be able to see why if you've done a real bad job. So if we've done a perfect job, the sleeving should line up perfectly with the back of the connector. And not quite. I should have had a little bit more of a gap. But that's it. There we go. Just needed to push it a little bit harder. But the sleeving should line up perfectly with the back of that connector, whereas the heat shrink should go inside a bit. The heat shrink has to be over the first crimp or it's got nothing to properly grip onto. So normally I might have a little bit less heat shrink, and this is another big problem for heat shrink. If you can imagine, you've got a whole lot of wires, mainly on a 24 pin with heat shrink. Well, how are you going to get the backs of all of the heat shrink to line up perfectly? Because if it doesn't, it just looks terrible, looks like an amateur job. You can cut the heat shrink to size, the same size, every piece of heat shrink. You can melt it onto the same position every time, but you're always going to get a bit of variation. It's incredibly difficult. So that is heat shrink. Let's do heat shrinkless, and I'll show you how much more fun it is and how much better it looks. Now, I have a bit too much length on this end. I need it to, for heat shrinkless, instead of it being way back here, it needs to be halfway across the second crimp, which is the crimp on the wire. So a lot further forward, a lot more strength. So always, after you've done your first one, you're going to start your second one, you pull the sleeving taut. And there's a little bit of a test to know how taut it needs to be. Really, the tighter the better, but you don't want to take it too far. You don't want to go crazy with it. But you bend it, sharp bends, and if it doesn't bunch up, then you're all good. This helps it look better, more uniform. It also helps the wire train better, you know, sit in the position you want it to. So I need to cut about 5 millimeters off. Now, this is what I was saying before. If it's too short, you've got to start again. If it's too long, and you know, people might think that this means you're an amateur, but whatever. There's no big deal with just grabbing your side cutters and taking a little bit of length off. I mean, you're not going to guess the length of your sleeving to perfection every time. I mean, it's fine if you're doing just one type of wire over and over again, then you're going to get it right. But if you're doing all sorts of different wiring, which, you know, which I always do, because I'm doing all of the custom wiring in my builds, well then, you know, you're not going to get it right every time, because sometimes you have one wire, two wires, three wires, four wires, and, you know, it just goes on, and it's different every time, because this is what I was meant to mention before. The reason, you know, the gauge of the wire changes the length that you need is because the thicker the inside is, the less the sleeving is going to stretch. So I won't stretch this one too much because it's just a rough example, but there you go, about halfway across the second crimp. Grab my heat shrink. Oh yeah, and after you cut it to length, you melt it again. So always do that. Every time you cut sleeving, you melt it. And with my heat shrink, I'm just going to go over the end of that sleeving, just past the end, which is very important. Make sure you don't go up and onto the active part of the pin. These little tabs here, those little tabs just there, that's what clips the pin in, or helps to clip it in. So if they get even slightly bent, it's not going to work properly, or it's not going to fit into the connector properly. Now, instead of just heating the heat shrink and shrinking it, this time we're melting it. And you're not really going to know how much you need to melt it. It's something that you just have to experiment with, because I don't know what burner you're going to be using, and you know, the heat of it, the heat shrink type you're using, the sleeving type you're using, it changes everything. So I've just melted it. You can probably see the smoke, and wait 5 seconds. You don't want to cut the heat shrink off right away, because you might end up damaging the melt that you've done on the sleeving. You need to wait for them to kind of cool down and separate a little bit. You can see how nicely melted that heat shrink is, sleeving is all the way around, melted into the pin. You know, it's melted into both of those crimps, it's melted onto the wire, the insulation. I mean, I could almost tow a car with that thing. It's not going to go anywhere now. And best part about it, plugs in so much more easily, absolutely beautiful. Sleeving goes right inside the connector, nice and clean, no heat shrink, just more superior in every way, there's no doubt about it. Now, if you can see melt past the connector, you need to do it again. You can have as much melt as you want as long as you can't see it outside of that connector. So that's really all you need to be careful of there. So that is the main type of cable. Let's do well, I'll just give you a quick look at a SATA data cable. Now, I like to use Bitfinex Alchemy because of the shape of the connectors. It makes them easy to sleeve right up to and run the heat shrink right up onto them. But this is just an example of the different things that you can do when you have the necessary tools and materials. You know, I like the stock sleeving, but I need all my sleeving to match, obviously. And the great thing about this is you can run your sleeving right up to here and then your heat shrink right up to here, whereas, you know, some other SATA data cables you can't do that. So often I will use other SATA data cables because, like I was saying before, build everything from the ground up except maybe your fan wiring. You cannot build these from the ground up. You just have to buy these, find the length you need, sleeve it, modify it. Well, you can't modify it. I have tried to modify these before, but cut one of these open and you'll see what I mean. I don't think anyone really successfully modifies these, and there's so many different brands and lengths out there that you don't need to. Just grab one and sleeve it. Now that you've seen how I've created one cable, that pretty much goes for everything. All that you're going to need to really do to figure out the rest is a little bit of experimentation. So that's about it. If I was going to go into full detail, there'd be so much more I'd like to cover, but you know, a lot of it you guys can figure out for yourselves. Just grab the tools and materials. Wiring is, you know, certainly not as expensive as a lot of the other things out there that we do, so it's something you can experiment with a little bit more. Something else you may want to look into, and you can see I have a good collection of it here, is custom wiring cable management. And we have cable combs, a lot of different options. You know, I like these kinds of things for sticking on and helping to hold your cables in position. Different types of cable combs. So if you're going to go to the trouble of cable management, it's nice to have things like this to add that little extra touch. But that's about it for this video, and I hope this information will be helpful. Thanks for watching. Please subscribe, like and favorite if you want to see more.